Okay. So this is the question, right? Hello? Hello?
Wait.
Let me know when you're ready.
Hello.
Yeah. Ready? Hello? Hello?
Hello.
Yeah, can you hear me? Can you hear me?
Hello.
Can you hear me?
Yes.
You sure? Can you hear me, right?
Yeah.
Okay. So, okay, let's start with this question. They say that n choose 1, n choose 2,
Okay.
and n choose 3. They are an AP. So what does an AP mean? An AP means that there is a common,
Common difference.
correct, common difference. So which means from here to here, I'm going to add D. From here to here, I'm going to add D. Okay. So firstly, we need to elaborate what is n choose 1 first. N choose 1 is basically n, right? Yeah. What is n choose 2? Okay, n choose 2 we have to use the formula already, which is n factorial over
2
what?
factorial.
2 factorial
Over. Yeah.
n minus 2 factorial.
Wait, why n minus 2 factorial?
That's the formula, right?
Wait, I don't have the formula. Wait. Let me see the thing.
If not, you can Google up.
Oh,
HL formula booklet.
okay. But I cannot find a formula for this. PNC they never say.
Let me find for you. Okay, I just send you the link under the chat.
Okay.
Click on it and you'll be able to see.
I don't think your notes mentioned this.
Mention what?
The formula just now.
Oh, because it's in a formula booklet.
Huh? Oh.
Yeah, my notes did not mention it because it's in a formula booklet. You know what I mean by formula booklet?
The IB one.
Yeah, the IB one. I just sent you a link in the chat.
Oh.
As in not the WhatsApp chat. In the Zoom chat. Do you see it?
Yeah.
Yeah. So because this is in a formula booklet, I usually would not put it into the notes that I give you, the concept map that I give you. Yeah.
Mm.
Because this is something that belongs to year 1 to year 4. You understand what I'm trying to say? Because year 1 to year 4, you will probably encounter combinations and permutations really.
For
In E-math or A-math, you should have seen this before. Like under binomial, you should have seen this before. Okay, can I move on?
yeah.
Do you see it? Do you see the formula?
No, not yet.
Just scroll all the way down, you should be able to see under permutation combination.
No, like the Wi-Fi very slow.
The what?
The internet here very slow.
Oh, you are at home, right?
Yeah.
Oh, but the internet at your place is quite slow.
I don't know why, suddenly very slow.
Okay, never mind. I can share with you. Can you see this? Can you see the screen? Hello? Hello?
Hello?
Yeah, can you hear me?
Oh, yeah, can hear you.
Yeah, actually,
Oh,
because your router is at level 1, is it?
no.
Or your
I
router
don't
is at
know.
your router is at level 2.
Uh, it used to be damn fast, but now I think these few weeks, this year onward, I don't know why it's so slow.
That's weird. Are you using Singtel?
Yeah, StarHub.
Oh, okay. Um, Never mind. But now you can see what's on my screen, right?
Yeah, but sometimes like it's lagging cause the Wi-Fi is only 1 bar.
So bad ah.
It's I don't know. It's only on the phone is 1 bar, but on the computer the same Wi-Fi is like full bar. I don't know. It's very weird. But it's also computer.
Oh dear. Can you hear me?
Yeah, okay.
Okay. So this is the formula over here.
Okay.
Can you see this formula?
Yeah.
Okay. So I'm going to go back to the question. So coming back to this. Okay. N choose 1, N choose 2, N choose 3. Plus D. Plus D. N choose 1 is N. N choose 2 is N factorial over 2 factorial N minus 2 factorial, right? Hello? Are you there? Can you hear
Hello.
me?
Yeah, can.
Wow, okay. Sounds very smooth. Okay, we carry on.
Okay.
Okay, so n choose 2 equals to n factorial over 2 factorial multiplied by n minus 2 factorial. Then n choose 3 will be equals to n factorial over
3
3 factorial.
factorial.
Yep,
N minus 3.
yes, correct. Hey, do you use a laptop or iPad?
I'm using my phone.
Oh, you're using your phone right now.
Yeah.
But when you use the laptop, it cannot work.
I don't know why I can't download it on my laptop.
Okay. Never mind. Later when we take a short break, you can try to you go to Zoom and then you download Zoom on your laptop. You use Mac, right? Do you use Mac or Windows?
Yeah. Mac.
Okay, later you try to download when we have a short break. Because if you use it on your phone, right, it's too small. I'm not sure if it will be clear to you.
Okay.
Yeah. If you have iPad, even better. Then you can, if you have an Apple Pen, you can draw on it.
I don't have.
Okay, then never mind. Then just use your Mac later. But currently, it's still visible to you, right?
Yeah.
Okay. So n choose 3 equals to n factorial over 3 factorial times n minus 3 factorial. So from here to here is a plus d. From here to here is a plus d. Okay, we need to find what is n. So basically, there's a relationship here. Okay. So right over here, we can simplify this. Simplify this into what? Huh? Ethan? Remember we did this last lesson? Because n factorial is n times n minus 1 times n minus 2, so on and so forth, all the way to times 1. So n minus 2 factorial is actually n minus 2 times n minus 3, so on and so forth, until 1. So we can cancel this with this.
Yeah.
Make sense? So what we are left in the numerator is n times n minus 1 over 2.
Wait, how do you get it?
Because n factorial divided by n minus 2 factorial,
Or just cancel out.
yeah, from here.
Oh yeah. Okay.
Make sense?
Yeah.
Yeah. Then after which, from here, we are going to have n times n minus 1 times n minus 2 factorial, n minus 2 over 3 factorial is 6.
Yeah.
Make sense to you?
Yeah.
Okay. Then from here, okay, because we have a relationship, they are an AP, right? They're an AP. So AP means, right, when I have TR plus 1 minus TR, we are going to get a D. This is what constitutes an AP, right?
Yeah.
Make sense to you?
But can't you just put NC to minus n choose 1 equals D?
Can, but because the reason why I want to put it in this way, because straight away I can express it that n times n minus 1 over 2 minus n is equals to n times n minus 1 n minus 2 over 6 minus n times n minus 1 over 2.
Yeah.
Agree?
Yeah, agree.
Yeah, because this is equals to D. This is equals to D. It's very clear.
Okay.
So just by solving this equation, you will be able to find your answer.
Okay.
Can?
Can.
Okay, so this one I will just leave it for you to solve lah. We will not solve it during the lesson itself. Because from here it's
Okay.
just very normal manipulation.
Yeah.
Okay, great. We'll move on to the next question.
Yeah. Of this binomial question I sent you yesterday, I'm not so sure.
Okay, we will go through every single question that you sent me.
Okay.
Okay. Meanwhile, as and when you need a break or need a toilet break, just let me know, okay?
Yeah, okay.
Yeah.
Oh yeah, for this one, Kenny, I managed to solve A and B, but it's C that I don't know how to do.
Okay, let's take a look.
Yeah.
So oh yeah, for your school, so you all also will have like once a week of e-learning or something, right?
Yeah, very stupid.
Which is on which day?
Thursday.
Thursday. Okay,
Yeah.
so which is an opportunity for us. So every Thursday, right,
Yeah.
since you have time, right, if you have anything that you want to consult me, we can do it on Thursday.
Okay.
Yeah. Don't worry,
Supposed to be what? Yeah. Supposed to be
usually,
Friday, yeah.
sorry again? Is it
Supposed to be
Thursday?
Friday, but then my school changed to Thursday.
Oh, okay.
Yeah.
But this is also a good opportunity for us because understand that you won't have the physical at you won't have physical education in school. So
Oh really? No PE?
no, as in like the physical classroom education.
Oh, I thought PE.
Yeah, the physical classroom education. So over here on the online side, we'll be able to catch up on a little bit more things.
Okay.
Yeah, on Thursday itself. Because like that you have more free time in the morning or afternoon, right?
Yeah.
Yeah. Need not be a 2-hour session. Like if you have queries, we can just do a very quick 15 to 30 minutes consultation, then we can be done. Or we can just go through 1 or 2 questions together.
Yeah.
Like remember I told you 1 question a day?
Yeah.
Yeah, we can do that as well together.
I did 1 question a day, but that was not I didn't do the AP chapter, I did the others.
Never mind. Well done, Ethan. Never mind. It doesn't matter what you do, but it really matters that you do it.
Okay.
Yeah, it really. But I'm very glad to hear that you really did 1 question a day. But this one only you will know lah. Okay.
Yeah, but I didn't do the AP and AP.
Doesn't
I
matter.
did
Doesn't
the
matter.
other.
It's okay.
Yeah.
As long as you do 1 question, even one, if that day you really don't feel like doing it, you can do just 1 part of a question. Yeah. Okay. It's like you don't have to have a very long conversation with your friend, right? You just drop, hey, hi, what are you doing? That's all.
Yeah.
Yeah. Okay. So part 11a expressed in partial fractions. So after that, you will get like, because it's 3x minus 1 over, you'll get like something like x minus 3x plus 1. Right?
Yeah.
Sorry, equals to, then you have a over x minus 3 plus b over x plus 1. So from here, what you will get is your a x minus 3 to the power of minus 1 plus b x plus 1 to the power of minus 1. Then from here, you will use the formula that I gave you on the formula sheet, on the cheat sheet that I passed to you under Maclaurin's. Then from there, you can just substitute the values in, right, to get to your b. So that one is okay. So state the general term for the expansion. State the general term of the expansion and range of values of x for which the expansion is valid. General term for the expansion.
Yeah. At first I thought I must use the binomial general term, but then I asked my friends, they either forgot how they did it or they don't know how to do and left blank and submit, or they say that it's not binomial theorem expansion, it's just a general, it's just
it's a formula for it.
But my teacher said that I asked her, she said that you must just observe
a pattern. Correct. Because so it says
you don't use a formula.
So you see, understand the setter's intention. Setter's intention is very important. You see, understand how they create the question. They gave you here from partial fractions, then they want you to use hands to solve, means you want you to use part 1 to solve. Then from here, with these first 3 terms, they want you to state Means from this first three terms, you are supposed to state the general term, means you are supposed to observe a pattern.
But there's no pattern.
Okay, are you able to take a screenshot and send me? Or maybe you can just take a screenshot and send me the answer for the first three terms.
Okay. Because I submitted this worksheet already, but I'll see whether the answer. Oh yeah, here, okay. I sent on the Zoom chat or the.
Both are fine.
Wait, how do you go to the chat? Oh, okay.
Yeah.
How do you use this? Wait, how do you attach a picture to it?
Never mind, then you send to WhatsApp. Oh.
Okay. Yeah, I sent to you already.
Okay.
Oh, and my school.
Hello?
Hello.
Yeah.
Hello.
Yeah.
My school, they already went through proofs, which I don't know how to do. And now they have gone on to the next chapter after proofs, which is the real numbers or something.
Okay.
Complex numbers.
Remember that I told you to send me the online version?
Online. Oh, of the but we are not using a textbook, but we are just okay.
Yeah, it doesn't matter. I just need the online version of it. Remember, by today can?
Okay.
Then so it'll be good if we can at least do one full regular lesson and then maybe half an hour to 1 hour consult on maybe every Thursday, so we can catch up with your school.
Okay.
Yeah, I think it's better that way lah. But as of now, from what I see, APGP and PNC, you are definitely more on track.
Yeah.
Yeah,
It's the others.
Yeah, correct. Because those are new. If you're feeling
and binomial, I'm okay.
Yeah.
Binomial, partial fractions, all this I'm okay. It's just the proofs now. APGP is still a bit. Sometimes can, sometimes cannot.
Which
Depends
means more
on the
practices
question.
have to be done. Yeah, which means more practices have to be done. Previously, we did. Let's see. Okay. Maybe today we can run through a bit of proofs.
Okay.
Okay, let's take a look here. So this was the first three terms, right?
Yeah.
Yeah, this was the first three terms, as you can see over here. Right?
Yeah.
So right now, they say state the general term.
Okay.
So we have to find something. We have to find something. So 1/3, maybe I want to put it into 3/9 minus 11/9x plus 7/9x squared.
Okay.
Yeah. So from here, we have to see a pattern.
I only can see that the denominators are all 9, and they're all ascending powers of x. That's all.
Okay, ascending powers of x. So 100% we know that, okay, it must be x to the power of something, like x to the power of, say, x to the power of, we use any letter, we say r, okay, x to the power of
Yeah.
r, right? So we know x to the power of r definitely part of the pattern. Then now we look at 3/9, 11/9, and 7/9. I understand that here there's a negative sign, okay? But let's deal with this first. From 3/9 to 11/9 to 7/9, how are we going to do that?
Uh,
Well, actually this one is like a hit or miss. For this question, it will be something like a hit or miss.
a lot of my friends say that they just left it blank and they just submit.
Yeah, because this one is you only can guess it. There's no way that you can do it mathematically with any form of analysis.
Wait, you can't? I thought they must. Oh,
Mm,
is
it's
this
not.
is this a common question in IB?
Sometimes in
Or
IB
is
they will have something like that. Because now your syllabus change, is also, that's why I say that I will need your book to understand what kind of questions will come out.
oh
Yeah. But have to go according to what your school gave you also. If they give something like that, means there's a slight chance that this thing might come out. Okay. X to the power of R. Wow, this one is a bit impossible to guess. Looking at the answer, it's impossible to guess it. But most likely this thing is only 1 mark. Okay, so there's no need to be so
like I know some of my friends they actually got the answer and they still use the formula, but then I look at it and I don't know how they got it.
what formula?
The binomial formula. They were saying the can I take a picture and send you on WhatsApp?
Yep.
Yeah.
Binomial formula.
Some of them I asked them if whether can use general term or not. And they said some say use a general term for binomial, some say don't use. They all give very different answers.
Oh. I see it, I see it. This is in your book.
Yeah, it's in my book. They put some useful results, but I don't know how you can make use of that.
Can be done. Hold on. The Maclaurin's formula, did I provide it? What? Maclaurin's.
Lawrence.
Remember I give you the cheat sheet for Maclaurin's?
Binomial, you mean?
Yeah, there's this binomial one. Oh,
Oh,
I did not insert it in.
Don't have inside.
Okay, doesn't matter. Let's use what your school has over here. Okay, so I think what your friends meant was this formula here.
Yeah.
This is the formula that they want you to use.
I don't understand
Okay.
why I must use.
Okay, because with regards to this or this, if you were to choose a formula to use, it has got to be the second one because of this minus sign over here.
Where? Which minus sign?
This one.
Oh. Okay.
Because you see, this is plus, this is minus. This is the only this thing is the only equation, is the only format that has negative.
Okay.
Okay, so as you can see, given this format,
Yeah.
we have this minus 1 to the power of r, x to the power of r. But in order for us to even use this formula, the first term has got to be 1. But our first term here is 1 over 3. So from 1 over 3 minus 11 over 9x plus 7 over 9x squared, we have to take out 1 over 3 first. So after taking out 1 over 3, we are going to be left with 1 minus 11 over 3, right? Plus 7 over 3 x squared. Sorry, there's an x here. Okay?
Yeah.
Okay. So from here, so using this formula, we can see that we have a minus 1 to the power of r. which means when for the first term is where r is equals to 0. First term r equals to 0, we are going to have minus 1 to the power of 0 and x to the power of 0, right?
It's basically all 1.
Yeah, it's basically just 1. That's why you have this one over here.
Wait, how does this relate to the actual answer?
Okay, because we are trying to strike a resemblance. We are trying to strike a resemblance between, because now they ask us to state the general term of the expansion. So
Yeah,
so this one, this polynomial
yeah,
here will either only
yeah.
fit this or fit this
The
formula.
bottom one, because of the negative sign.
Yes, so got to be the bottom one. But the thing is now we have to do some manipulation to fit into the bottom one.
Okay.
Okay, so now what I did was I took out 1/3 first. I took out 1/3 because there is in order for us to even fit this formula, right, we have to make sure that the first term is 1. We have to make sure that the first term is the number 1. Because right now our first term is 1/3 over here.
Okay.
So that's why I took out 1/3 first. Okay. Then
Yeah.
for the x, right, you see there's no x here. Can you see?
Yeah.
There's no x here. There is
So it's x to
x.
the power of 0.
Yes, this is x to the power 0, this is x to the power 1, this is x to the power 2. That's why we have x to
Yeah.
the power of r. R starts from 0.
Yeah.
Right?
Yeah.
Makes sense to you, So from here, what we
Yeah.
can do is we can already take out. X to the power of r. Make sense? Because r will be in ascending order. You start from r to the power of 0 for the first term.
Where did the xr come from?
Because here is x to the power of 0, right? This is x to the power of 1. This is x to the power of 2.
Yeah.
Yeah. So if I were to multiply this x to the power of r in, I'm going to get 1 over 3 x to the power of r minus 11 over 3 x to the power of r plus 7 over 3 x to the power of r. But this r
But
will
the
be...
powers will always be different.
Yes, correct. So if this will be 0, 1, and 2. Because now I'm trying to find a formula.
Okay, so the value of r can be different
It has to be
at any one
different.
point of time.
It has to be ascending. It has to be ascending.
Oh.
Because of what we have here. Can you see?
Actually, I don't understand how that formula is being derived.
This formula,
Yeah.
the one that I boxed up, is it?
Yeah, this one.
Okay. If I have from 1 minus x plus x squared minus x cubed. So by using this formula, right, we can see that when r is equals to 0, what will we get? We have minus 1 to the power of 0,
Yeah.
x to the power of 0, which is 1. There you go. When r is equals to 1, what will you get? Try to formulate it.
Negative x.
You get negative x, right?
Yeah.
When r equals to 2, what do you get?
X squared.
Correct? Oh? That's why this formula, this general formula fulfills all these things. If you fulfill every single term in this expansion.
Oh.
Understand?
Okay.
Yeah. So over here, right? For this whole box here, right? Don't need to worry too much. This is just a very, very, very unique case. It's a very, very unique case. There will not be
Then you
any.
you can just expand it normally and then to memorize all this. No?
Yeah, you can expand it normally, but when they ask you to state the general term of the expansion, you have to use this given result that your school left it for you in the book. Because now they say state the general term.
But then some say, like my teacher say, just observe the pattern without using any formula.
That will be
And
quite
some
tough.
say, oh,
That will be quite tough. Can be done, but it will take a lot of time. And in examination context, it is not worth it. I'd rather you give them the mark. I'd rather you give them this 1 mark so that you have more time for other marks. You understand what I'm trying to say?
yeah.
Yeah. But right now, because we are having a lesson, right, it is still okay for us to go through this thing. But in an exam, in an examination context, you have to be very, very smart. Are you overcompensating your time? Are you overcompensating for this question? Are you shortchanging other questions? That's what you gotta ask yourself. Yeah, because this one is just a state. You see, state means only 1 mark. State the general term, 1 mark. State the range of values, another 1 mark. Where's the range of values? The range of values is here.
The range of values will always be modulus x less than 1, right?
Yeah.
Okay.
It will always be.
Okay.
Yeah. So over here, okay, this is honestly quite hard to see, but we can see that the x is in ascending order. We can straight away see that, okay, we are going to have 1/3 x to the power of r and minus 1 to the power of r already. So in which we are only left with.
Where do you get that from?
This thing is from here.
Yeah. Wait, what? How is that related to this?
Okay, let me repeat. Okay, firstly, this is our result from part B. Okay?
Yeah.
They ask us to state the general term of the expansion. What is the expansion? This is the expansion. This is the expanded polynomial. Make sense?
Oh, okay.
Okay. From this polynomial, we are supposed to state the general term. Means we are supposed to find the formula that fits this sequence, this series. Means that there is a formula such that when we replace the r in ascending order, we are going to get 1/3, we are going to get minus 11 over 9x, we are going to get 7 over 9x squared.
Okay.
You understand what I'm trying to say?
Yeah, yeah.
There is a given formula. Okay. So right here, your school already provide you with some useful results, which is really very useful. Okay. And we found that we have to use the second formula instead. Why do we use the second formula? Because of this minus sign.
Minus.
It coincides, yes. It coincides with this minus sign over here.
Yeah.
Okay. So up front, we already know that this formula here okay, it will have a minus 1 to the power of r, x to the power of r from here. Understand? This is just going to be part, it's going to be part of the formula for this polynomial. It's going to be part of it only.
No, but I don't see the pattern also. Like they say 1 minus x plus x squared minus x cubed dot
Yeah,
dot
yeah.
dot.
It's different.
And they give
100% is
this.
different. 100% is different. You see this one and this one,
Then why
right?
they just
It's
no
different.
why they add? But then how from this they got all the way to negative 1 power r.
You can draw.
I get it.
You can
Oh
draw.
yeah, I get it. Yeah, I get it. But
Oh,
then
yeah. Because this thing is just a formula. This one is just a formula for every single term here.
oh yeah, it's general term.
Yeah, it's a general formula. It's a general term. Understand? So this expression here is also a general formula for all this. But of course, you see, as you can see, if you compare term by term, it doesn't fit. It doesn't resemble at all. Right? This is 1, this is 1/3, this is minus x, this is minus 11, 9 over x. This is x squared, this is 7 over 9x squared. It doesn't fit at all. Which means, right, something has been done to this polynomial. Something has been done to give me this. Okay, so now what we are trying to do is to find out what has been done, what has been added to this general formula here, such that it became this. You understand? But I'm not done with my explanation yet. Maybe you listen to my explanation first.
Oh,
I'm not done with my explanation
okay.
yet. Yeah.
Then I kind of get it.
Yeah. But what I need you to understand is that, right? What I need you to understand is that this minus 1 to the power of r, x to the power of r, right? This general formula is inside each of these terms. It's just that there is something else to be added or multiplied or divided by to this thing to get to these forms. Okay? You listen to my explanation first. Can?
Can.
Okay. So one thing that we can be sure of is that this general formula applies to this. It's just that we need to find what has been added, multiplied, divide, whatever. I don't know. I'm here to find out.
Okay.
Okay. So over here, we can see that the first term here is 1, but the term here is 1/3. So 100% we know that we have to take out 1/3 from every single term to make the first term 1. We have to ensure that the first term is 1. Okay.
So I'm trying to make our answer like the formula.
Yes. We want to make our answer similar to the formula.
Okay.
Correct. Okay. So now we'll take out 1/3. So when we take out 1/3, right, we are left with, and you see we took out the x to the power of r, right? So what we are left with is 1 minus 11. Sorry. We take out 1/3, we are left with 11 over 9 plus 7 over 9. Minus 2 over 3. 1/3 to the power of r. I'll get 1/27. When we take out 1/3, so all this will become plus. Because we took out the -1 to the power of r, which means everything will become plus here. Because when we multiply this -1 to the power of r in, that's when we get minus plus minus plus minus plus.
But that depends on the R value. If the R value is an even number, it's going to be positive.
Correct, correct. That's why now this becomes a positive sign instead of negative sign. Because for the second term where r equals to 1, that's why this 11/9 will have a negative coefficient.
Then the 7/9 should be negative. What?
Should be positive.
Huh? Negative because it's power 3.
No. This is r equals 0. This is r equals 1. This is r equals 2.
R equals 2.
Remember, I just mentioned r starts from 0.
Yeah. Oh.
Yeah.
Wait, then 11/9 should be negative.
Yeah, correct.
Isn't?
Yeah, but because I
But
took
why
out
is
the
it?
-1 to the power of r.
Wait, where? You didn't take it out or what?
Here.
Oh, wait. Huh?
Because if I multiply -1 to the power of r into all these terms again, right? I'm going to get 1 minus 11/9 plus 7/9.
What?
You have to see it. You have to see it like a formula. You cannot see it like normal mathematical expression. You have to see that when I multiply this -1 to the power of r in, I'm going to get 1 times -1 to the power of r plus 11/9 times -1 to the power of r plus 7/9 times -1 to the power of r. This r is going to change values from 0, 1, and 2. Because I'm trying to find a formula for this. I'm trying to find a formula for this.
I don't get it.
I tell you what. When I see you again, then I explain to you in detail, because I think this part, right, does not deserve so much time. Yeah.
Okay.
Because this is going to be 1 mark. If you cannot get it during exam, right, you should not be overspending time on it. It's not a smart move.
Yeah.
Yeah, you understand what I'm trying to say, right?
Yeah.
But basically, later on, if you have time, you go and relook at what I'm trying to explain. You can rewatch the video again. It will help a lot if you rewatch the video again. Can?
Okay.
Yeah. Because just remember this, what I'm trying to say here is that we are trying to find a formula. We're trying to find a formula for this.
Yeah.
Yeah. There is no R.
Then
There is no R inside this expansion. There is no R at all. Where did this R come from? This R came from the prefix formula given by the mathematicians.
Yeah.
You understand what I'm saying? There's no R here. There's no R here at all.
So it's as if you're factorizing out the formula first.
Yes. I am
then
factorizing.
You factorize out 1/3.
Yes, correct. Because I know that this formula here is is within this polynomial. Because
Yeah.
we found resemblance between this polynomial and this polynomial. That's why I know that there's for every term in this polynomial, there is this prefix formula inside it. It's just that there was something else attached to it that make it 1/3, that make it 11/9, that make it 7/9, instead of 1 minus 1x and positive x squared.
Okay.
That's
But
why
then why 11/9 is not negative over there?
because I took out the minus 1 to the power, because I've already assumed that minus 1 to the power of r has been factorized out from this polynomial. Because when I multiply this minus 1 to the power of r back in, right, according to the sequence, as r increases, the minus 1 to the power of r will be minus 1 to the power of 0, minus 1 to the power of 1.
So it's positive because you took out the negative.
Yes, correct.
Okay. Yeah, and I think I can get it a bit.
This is the reason why there is the r here. It's like, because this factorization is is very, very different from the kind of factorization that we do last time. Because now we are trying to find a formula. We have to assume that this r will change values in ascending order.
Okay.
Yeah. So from here, okay, I'm just going to finish explaining this thing, so that after that you can rewatch this video to understand better.
Okay.
So the good thing about YouTube is also that you can fast forward the clip, like you can play it at 2 times the speed, so it won't be so slow.
Okay.
Yeah. So after I take out 1/3, this is what I'm left with. So over here I have 1 plus 11/9 plus 7/9, which is also equals to 1 plus 18/9, which is also equals to this will be equals to 36/9, which is also equals to divided by 9, it will be 4. Right? Is it 4? Okay. 1 plus 11/9. This is 4/9. Correct, right? So 18/9 plus 1, 36/9. Number 3 to the power of r. Wait, hold on. Okay, I think if I were to explain this further, right, I might confuse you. Okay, never mind, Ethan. I tell you what. This one, we have this question, you circle up this question somewhere. I'll explain to you when I meet you in person. I think that one is easier.
Okay.
Can, right?
Can.
Okay, but for the next part, the range of values of x for which the expansion is valid is just this.
It's just the modulus x less than 1.
Yeah, correct. So when you do this question during exam, right, if this is the only part that you couldn't get it right,
yeah,
you only minus 1 mark.
Oh, okay.
Okay, because the goal is not to get 100 marks, right? But if we overcompensate for this question, we will deprive ourselves from getting a 7 really.
Yeah.
Okay, let's move on to something else.
How about the question I sent you yesterday? The question.
Yeah.
Question 3.
Hold on.
Yeah.
Okay. Find A if the coefficient of x in the expansion of this is 0. Okay, we do not look at the second part first. We focus on this part first. Okay? We focus on this part first. So we have to expand it first. So firstly, right,
Yeah.
we have two terms here. This is our first term. This is our first term. And we have another term which is okay. We want to find A, okay, if the coefficient of x, find A if the coefficient of x in the expansion of this is 0.
Like, I think I know how to do this, but my way is this very tedious. I have to expand the whole
You
thing
expand
first.
everything.
That's the only way.
No,
Is there
as
any
in
shorter
you
way?
expanded the whole thing, is it?
I stopped halfway because it was a lot. It was really a lot. It was
Yeah.
like it was
Yeah,
it was like four terms times 8 terms. And I don't know how to multiply anymore. I think I got lost.
definitely not a good idea to expand everything.
Is there a shorter way?
There should be, but let me think. Find A if the coefficient of x. Oh, okay. They said the coefficient of x. This is something that we miss out. Which means when x is to the, when coefficient of x means what? They want the number that is beside the x term.
Yeah.
So all we need to do is just find the x term for this and to find the x term for this.
Which one? Wait, which one again? The x term for
the x term for this, the x term in this expansion, and the x term in this expansion. That's all we need to do.
Oh.
Okay. So the trick to find only the x term in each of the expression. But the question is how? Right?
Yeah. Do you want me to send you what I've already worked out?
Okay, don't have to first. Because you expanded everything, right?
I expanded 1 plus 3x to the power of 4
Okay,
and 1 minus x over 8.
because we are not supposed, this question wasn't constructed, right? The setter that created this question, right, wanted you guys to expand it. Okay, he wanted you guys to fall into this pit hole to expand it and to waste a lot of time. But in actual fact, right, you are not supposed to expand it. Students who expand it, right, they'll be in very, very, very deep trouble. Okay, but so how are we going to do this, right?
Yeah.
This is what we want to do. Okay, so now we only want to find the x term. Means when this multiply by this, we just want to know what is the x term in this, right? Okay, so from here, let's say if we can find the x term in this expansion, we multiply by the constant term in this expansion, we will get the x term, right?
Yeah.
Make sense?
Yeah.
Yeah. And also, if we were to get a constant term in this expansion,
How about, let's say, if all we manage to... No, wait.
okay, listen to me first.
Oh, wait, no, wait. I think I know. Is it, you just selectively multiply the those that will give you the coefficient of x.
Yes,
Then the
correct.
rest you just leave it out.
Correct. But the thing is, you're not supposed to expand. You're supposed to go and find that specific x term and the specific constant term.
Oh.
Which is what Mr. E probably would have taught you last year.
Mr. Yi taught me how to selectively multiply. Like,
Yeah.
if
correct.
you want x squared, then you must start times with whatever gets you x squared, that kind of thing.
Yes, correct. So now we want x term. Okay, so since we want x term, oops. Since we want x term, which means we have to find the x term in 1 plus 3x to the power of 4. Okay, then we multiply by, then we go and find the constant term in 1 minus x to over 8 to the power of 8. Because x term multiplied by constant term will give you x term. And the constant term multiplied by x term will also give you x term. Make sense? That's why the trick was to only find x term in each expression. Can?
Yeah.
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 Then after that,
so it always. Yeah. So it's a numerator integer times x value. That's all, right?
Need not be integer. I do not know what's that.
Okay.
As long as it's a constant. So same thing for this part. We're going to find the x term, and here we're going to find the constant. Then we multiply them.
Okay.
We can also find the constant term here. If there is constant term, then we can only do that. If there's no constant term, we cannot do that. Then we find the x term.
Okay.
Then after both sides is done, then that's when you can minus them, and then you equate it to 0.
Okay.
Because they say it is 0.
And I think the question, my expansion, there isn't much of a x value. There's only yeah. Wait. Okay. Yeah. But then how about the 1 plus 8x to the power of 4, 1 plus x power 3? That one need to do the same thing.
Same thing.
Or what?
Same thing.
But then you don't know that you don't know x. You don't know. I mean, you don't know a.
Because that's what the question wants you to find. After that, you put it into this equation, then you'll be able to solve for a.
Oh.
Yeah. So the formula that the crucial formula to use is this formula. Or could be the other way around. This should be in your formula booklet also.
Okay.
You understand? You have to apply this for every single one.
Okay.
Okay? Can?
Can.
Yeah. So maybe this one you can try it during your own free time, then after you let me know again.
Okay.
Wonderful. Okay, let's move on. You want to take a 5 minutes break?
Yeah, yeah. Okay.
Okay, let's take 5.
Okay.
Yo,
Hi, hi.
hi. Okay, so we're done for this question, yeah?
Yeah, yeah. I'm trying to solve it right now.
Okay. There was another question that you sent me, right?
There was. Oh yeah, there's the. Wait, what's that? Oh, there was this other. There's this other question that I haven't sent you yet. But
Okay,
I
you want to send me
think,
now?
yeah. Okay. What's that?
Yes.
Then how about the proofs?
Because of time constraint, right? Can we go through proofs
Yeah,
with you on another session, which is maybe this coming Thursday?
Thursday. Okay.
Yeah.
Okay.
Wow. Okay. See.
This
IB
one no one in my
questions.
class could do.
Yeah, IB questions is just very, very weird as compared to the A level kind of, because O level and A level kind of questions are more similar. IB
Oh
questions
really?
require yeah, because
Oh
do you
no.
take O levels? You took, right?
Yeah, I took O levels.
Yeah.
I like A math.
Yeah. A
I
math
like
and
like I
IB,
like
right?
A. Yeah,
Totally different. The
yeah.
set of thinking is different. The perspective towards the question is really different.
Like I like A math. That's why I chose to take HL math. But then now it's like it's so
You realize
different.
it's different, right? Yeah. Because if you
It's
take
so
if you take
different.
A math and then you take H2 math in JC, you will prefer it that way.
Yeah, I found A math fun. So I thought HL math would be okay. But then
It-
HL math is not fun, whereas A math was fun. I don't know.
correct. That's why it's always better to consult first before taking.
Yeah, they were
Yeah.
saying something like, oh, HL math is 10 times harder than A math, this kind of thing.
Hmm. Okay. Nonetheless, we don't have a choice lah, unless you can drop to SL math or something. But
Cannot.
yeah lor. If not, we
Yeah,
can only suck it up and push through.
yeah.
Yep. Okay. So for question 17, they say consider the binomial expansion of this. Okay. So it sounds like it's like it might as well you don't tell me lah, because we know that a to the power of n times a to the power of n is equals to a to the power of 2n lah.
Yeah.
Yeah, it's the same. Is we all know that lah, but we wouldn't see a to the power of 2n this way. We wouldn't see it this way. But they intentionally tell us that we have to do this. We have to do something like that.
Yeah.
Okay. So now we have to see how we can do this. So when they say show that, it's either you prove from left to right or right to left. Correct, right?
Yeah.
Because they said show that. So Mr. E probably thought you show that LHS
Yeah.
is summation k equals 0 and n k squared. So from here, we can see that, okay, is n choose 0 square plus n choose 1 square plus all the way to n choose n square.
Wait, summation means what again? In total,
Summation
is it?
means addition. Means if I have summation of r from k equals to 0 to n, it means that I'm summing, from r, this r. Means it will be from 0 plus 1 plus 2 plus 3 all the way to plus n.
Oh. Oh yeah, okay, I got it.
Because this is r and this is r.
So the bottom is the starting point, is it?
Yes, this is the ending point.
Oh.
Okay?
Yeah.
Yeah. So now from here, we are trying to get to this place. By using this. Okay?
Yeah.
So there's a reason why they told us what they told us at the top.
Yeah.
Okay. So let's see. So what we have here is n choose 0 times n choose 0 plus n choose 1 plus n choose 1 plus n choose n choose n. So essentially, this becomes n choose 0 is 1 times 1 plus n times n plus n factorial over 2 factorial times n minus 2 factorial.
Wait, this one applies again. I thought this is only for P and C.
So again,
Wait,
no,
how do you...
for all choosing, as long as you see anything that is like that.
How about when I learned binomial in A math, it wasn't like that, leh.
Now it's IB already.
Wait, so
What do
A
you mean by
math
you learn
is...
binomial? It's still the same. It has to be the same.
How about... Because I remember in A math, it was only like n prime over r prime.
You mean n factorial?
Yeah, n factorial over r factorial.
No, there's no
There wasn't
there's you mean that there wasn't like that?
I don't... Oh, yeah, I think there
You
was.
mean it was only like that?
Wait, let me check.
There's no such formula.
It isn't.
There isn't.
Oh. Oh, that's okay. Yeah. Wait, then okay, so n choose 0 and choose 0. N choose 0, is it 1?
N choose 0 is 1.
N choose 1 is n, yeah, then wait, then how n over 2. Wait. Kenny, I don't understand the from n how do you get n prime over
N
2
factorial.
prime over n factorial over 2 factorial n minus 2.
This formula. Because I n choose 2.
But on top, you just stop at n choose 1,
Yeah,
n
yeah.
choose 2.
I wanted to expand a bit more to see it.
N choose 2. Oh, okay. Yeah, then n choose n is 1, yeah.
Yeah, I wanted to
Yeah,
expand a
okay.
bit more to see it.
Oh, okay.
So oh, this one is how did they get 2n over choose n? 2n choose n is basically equals to 2n factorial over n factorial over 2n minus n factorial, which is equivalent to 2n factorial over n factorial times n factorial, which is equivalent to 2n factorial, which is equivalent to 2n times 2n minus 1 until times 1 until times n plus 1 over n factorial. And choose 0 and choose 1. Choose 2 factorial and minus 2 factorial. We have to use this. How are we going to include this inside this? Ethan,
Yeah.
Ethan, let me get
Yeah,
back to
yeah.
you on this one again.
Okay.
Yeah, let me get back to you on this one. But there is one thing that I want to tell you, which is there's this question on the triangle. Remember, A, B, C, then there's 3 dots.
Oh yeah. The PNC one.
Yes.
Yeah.
Yeah. So they ask you how many triangles can be formed,
Yeah.
right? Because let's say if you take A as a reference point, okay, if you take A as a reference point, so A can choose this, A can choose this one and this one to form a triangle, right?
Yeah.
A can choose this one and this one to form a triangle also. Or rather, A can also choose this one and this one to choose a triangle also,
Yeah.
right? So
Yeah.
basically, we can choose any 3 points to form a triangle, but there's a few scenarios where we totally cannot. There's some scenarios where there are some points we cannot choose to form a triangle, which is we cannot choose any points on the same line. We cannot choose all 3 points on the same line.
Mm. Mhm.
We cannot do this. So these are 3 ways where the triangle cannot form. Make sense?
Mm.
Yeah. So the way to do it is that how many points are there altogether? 1 point, 2 point, 3, 4, 5, and 6.
Yeah.
Right? So we out of 6 points, we are going to choose 3 points.
Yeah.
So 6 choose 3 will be the total number of triangles that we can form. Because out of these 6 points, we just need to choose 3 points to form one, right?
Yeah.
Yeah. Then after that, we have to minus.
Wait, why 6 and not 9?
Why 9? We only
Wait.
have 6 points.
Oh, yeah, 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 yeah. Oh, yeah.
Right. 6
There's
points, we
3
choose 3.
overlapping.
Yes.
Yeah.
6, we choose 3 points. Then after that, we minus 3. What does this 3 represent? It represents this 1, 2, and 3.
Yeah.
Then you should get the answer.
Oh, okay.
Understand? Okay, for question
Yeah.
17, I'll get back to you. Right now, I need to attend to Greg already. I need to attend to my
Okay.
next student. Okay?
Okay.
Yeah,
Yeah,
if
can.
not, later once I solve it, I will send a WhatsApp to you. Then
So
I'll see you on Thursday.
Thursday. Okay, Thursday can go through the.
Proofs.
Yeah. Okay.
Yeah, you let me know what time is good for you.
Okay.
Okay, bye-bye. I
Bye.
will share this on the YouTube so you can review the lesson.
Wait, the -3 is for why? Because of what again?
These 3 scenarios. Because I cannot
Oh,
choose these 3 points, I
oh,
cannot choose these 3 points, I cannot choose these 3 points.
oh. Okay, okay, okay.
Can?
Can.
Okay.
Okay.
Bye-bye.
Bye.